Everybody doing today? Good? Awesome. Let me tell you what we're doing today. We're going to go over homework 1. About half of the class has turned in homework 1. The other half are presumably still working on it. So I've cleaned up the instructions on it to sort of list in order the steps that you're going to want to do to get through homework 1. But I don't want you to just take it as a checklist, like do this, do that, I'm done. Okay? I want you to actually understand at least some level of the reason why you're doing these different steps. So I want to talk about that and go through the instructions, and then hopefully everybody finishes it really quickly, because like I said, I'm probably not going to be around much tonight. So homework 1, then I want to start talking about scripting. We're going to cover input, we're going to cover output, we're going to talk about variables, doing arithmetic on variables, and that will be enough to get us into ODP 403. So we'll talk about ODP 403. And then we'll probably talk about looping a little bit, because we'll probably have time left over. So any questions before we start on all of that?
Can you talk a little bit about, like, you mentioned on the first day of class, I think, like setting up a handshake between your machine and the Linux server?
Sure. And I'll pass around the sign-in sheet. So that handshake is actually pretty painless to set up. So, and this is kind of assuming that you have Linux running on your own machine, okay? If you're running Windows, I don't know what the procedure is, we can figure it out. But if you're running Linux or something Linux-like, such as what I'm running on here, you need to do that SSH keygen command on your own machine to create a key for that, that device. And when you do that, again, under your home directory.ssh, you have this ID RSA and this ID RSA.pub, right? And you want to look at the ID RSA.pub. Right, and that's your public key. Okay, so if you want to log into, say, the Linux machine without having to type in your password, log in the usual way and go into your SSH directory. And look at a file called authorized keys. And inside there, paste your public key. And that's all you got to do. Okay? But it's got to be named exactly authorized _ keys. And now from your machine, when you try to log into the Linux server, the server will look in here, find a public key, see if it matches the private key on your machine, and if it does, then it'll go ahead and log you in.
So I made a directory for a project, and I initialized it for Git and everything.
Mm-hmm.
So when I try to push the file onto the Git website, it says that there's no directory or repository that's actually there, so you can't protect it. Even though I did the full handshake, is it because I have to create something in the website first?
No, in fact, you don't want to create anything in the website first, because that'll cause a conflict.
When I first made it, it prompted me whether to make something or leave it empty. So I did make, I think it's a repository, but it's just my username. Should I delete that? And maybe that will let me.
If you were creating the account, that's okay, but if you actually created a project or a repository on GitLab called HW1, then you won't be able to use those instructions to push it over.
Well, it's called something else. So
okay.
There's nothing that's called homework 1.
So yeah, it should work. Did you do the git remote add origin step?
When I put, yeah, I did that.
Okay.
And just whenever I put the push, master, all
Mhm.
that, then it just says that there's, such repository.
Okay. Let me run through the newer instructions for homework 1 and see if there's something in there that maybe you didn't do or you did differently.
Okay.
So homework 1. All right. So here's, if you hadn't done anything yet, right? So obviously you need to create an account on GitLab, okay? And that's just a one-time thing in your life. All right. So you do that once and you're good to go. And on that how-to, right, this doesn't replace the how-to, you need to do that git config where you set up your username and your email and your editor if you like. Okay, so you still need to do that once you create your account. And that's a one-time thing also, once for life. Okay, so these steps here are going to be once per project. All right, so first thing I'm going to say to do is make a directory with whatever name you like to hold your project. You're working on homework 1, start a new directory. Okay, don't just do everything from the directory you log into. So makedir is the command, makedir hw1 makes a directory, and then go into that directory with the cd command, cd space hw1, and then say git init, and that initializes your local Git repository. And then say git remote add origin git at gitlab.com colon your git username slash and whatever you want the repository to be called on GitLab, which for homework 1 has to be hw1 uppercase, and then put .git on the end. And that's once per project. You're working on homework 1, you only had to do those steps one time. And now there's a triple of steps that you're going to do again and again. So you create a file, you edit it, you test it, you do whatever you have to do. When you're ready to put it into Git, you do 3 things. You do the git add, and then git commit, and then git push origin master. And it should be that straightforward once you've got all the I's dotted and stuff. It's really those initial steps that are the trickier part.
So it's the get remote add origin and then that string, but where it says username, put our username.
Put your username, yeah.
And then that's what.
That's what basically links your local repository to the repository on GitLab.
Interesting.
But it doesn't push things over automatically until you say git push origin master.
Okay, and that'll create that repository on the website?
Yeah, I don't think it'll create until the first time you say git push.
Okay, interesting.
Yeah.
Like primes it?
Yeah, it basically tells your local Git system what system you're going to link up to when you say git push.
Weird.
Yeah.
So if we put in like somebody else's username in there, what does
Mhm.
that do?
If you have permission to write into their repository, it would let you do that. But it's gonna, you know, if you had an SSH key set up, basically, for that username. It's basically a login
Yeah.
of some sort.
I thought you were saying that you can only do the keys if you're on Linux.
Oh, you can do them from anything, but I don't have the steps up here for how to do it from a Windows machine.
Okay, is that something we'll have to figure out on our own?
If you want to do repositories on your Windows machine
Gotcha.
and push them over, but I'm assuming people are doing all of this on the Linux server,
Okay.
right, which is where you already set up an SSH key and so on.
Gotcha.
Yeah. Yeah.
So I opened the authorized keys file, and I noticed that there's already code there, but I'm not sure if that's the same one I put in GitLab. So should I paste should I have both in there?
Put them both in there. If you've already got it in there, it'll say this key's already used.
All right.
And when you put your key into GitLab, there's actually an option for putting in information that tells you what that key is. So if we go to settings and SSH keys, you can put a title in here, which should be something meaningful, like this is linuxengrcs.com or this is my MacBook or whatever. Let's see how good my titles are. Yeah, they're pretty good. My drums have an SSID. That's good.
Like musical drums?
I think so. I'm not sure why. Oh yeah, I know why. The drums are wired. They blink. Yeah.
While you're here, can you, I named mine wrong, and then I tried renaming it instead of redoing it completely. Can we check if that worked? Just while you're there.
What's your Git name?
A. Dixon.
If it happens to be up here, we can tell, but yeah, I gotta go through and search all of those. So the cleanest way to do it is just to rename, just to create a new repository, right? Do that git remote reset origin, and then the git remote add origin with the proper HW1.
Question. So how do you copy and paste a data?
Oh, no, that's an excellent question. And we haven't really talked a lot about VI yet. But let's play with a file here. So there's a few ways to do it, but you kind of need to know some other commands. For example, if I delete this line using the dd command, I can come down here. If I hit the letter P, it'll paste it right there. Or if I've got this 3 lines up here I want to move somewhere else, I could say 3dd, and I could go somewhere else in my file and say P, and it'll paste them right there. Or you can do, they call it a yank, it's before cut and paste was a thing. I could say like 5 and an uppercase Y, and that yanks 5 lines into my paste buffer. And then if I say P, it'll paste them right there. So the direct answer is number uppercase Y will copy that many lines, and then a P will paste them right at your current location. But there's a whole world more to it than that, which we will go over at some point. Including I can take the whole thing and delete it and then paste it somewhere. And I can make multiple copies. All right, other questions? All right, so that should work for ODP for homework 1. And then there's another one-time step you have to do before the deadline, which is you have to add me as a reporter. All right, so go into your project, find settings, find members, say add, put in my name, Nick Macias, and it'll bring up Nick Macias and something else with a 3 in it. Just do Nick Macias, right? And under role, say reporter. It's the second entry, and that gives me read access. And that's just one time. So tomorrow I'll run a script which will go through. So when you actually do this. When you actually go into homework 1, there's a submit assignment button. So what you need to type here is your GitLab username, right? And then say submit assignment.
If I have accidentally submitted something that wasn't exactly like that, would resubmitting it probably
Yeah, just resubmit.
fix it for the script? Okay.
Yeah. That's nice. It bumps me all the way up. So tomorrow I will run a script, right, which basically tries to clone each of your repositories into a subdirectory on my machine. So there's a subdirectory for each of you, and into there it will try to create a subdirectory called HW1, cloned from your HW1 repository. Your repository's got to be named HW1, it's got to be uppercase, no spaces, nothing else in the name, 3 characters, because it's going to get cloned from a script, right? The alternative is I go through one by one and I hop over to your repository and figure out which one, and that's not feasible. So it's got to be named exactly what it's supposed to be, otherwise it's going to look like the assignment's not there. And I'll cut you some slack on homework 1 because this is the first time we're using Git for this, right? And so this is also important. So when I'm grading your homeworks, right, on Canvas, I can put in a grade. There's also a comment area. I will use that comment area if I need to talk to you about your assignment. Okay, again, you should have notifications turned on to notify you immediately. Because typically with programming assignments, what might happen is somebody will submit their assignment and they're missing a function and I can't test their code. Right? And it might be a 5-line function, but I cannot compile their code to test it without that function. Okay? That's a 0 on a 2-week assignment. Okay? I'm not that mean. So I'll post a comment saying like, hey, your archive didn't include this file, please send it to me as soon as possible. If you come to me 3 days later and say, I just saw your email, here's my assignment, you've basically gotten 3 extra days on the project. Okay? And I can't do that. That's going to come out as a 0. So it's really important to read those comments like when I send them. And particularly on homework 1, I'll be grading these probably on the weekend. So just, if you see something from Canvas related to homework 1, it might be something saying, this looked great, really nice work, or it might be something like, hey, I didn't find your repository, it looks like you named it something else. Please go ahead and make it the right name and resubmit. And like I say, I'll give you some wiggle room on homework 1 because it's the first time we're doing this. But in general, pay attention to the comments. All right, questions on homework 1? Did that help at all with your homework, or are you still not sure why it's not working?
Yeah, after class, I'll go through that process again to get back to you.
Okay, send me an email if it's still not working, or ask on Discord. Oh yeah, another comment I made in the earlier section. So I turned off my notifications on Discord because my phone was blowing up. So if you need to reach me, right? Thanks. If you need to reach me, send me an email. Okay, don't be afraid of email. I'm not going to yell at you for emailing me. Worst case, I'll say, good question. Let's talk about it on Discord. Okay, don't be afraid to use email if you want to reach me about something. I'm locked out of my account again. Can you reset my password? Don't trust Discord, right? Because nobody else on there can reset your password for you, presumably, right? And I may not see it if it's posted on Discord. So send me emails if you need to reach me. Discord, though, I don't remember what we're supposed to call our homework 1, right? You can ask that on Discord, and 20 people will tell you.
If you want to, I'm pretty sure there's a server setting that lets you have notifications on only when people
mention you.
Yeah.
Yeah. So I've got that turned on, but not everybody would do that.
Yeah.
So, surest way to reach me is send me email. But yeah, thanks for pointing that out. All right, let's do some bash scripting. All right, so I'm in an empty directory. We're just going to play around with some shell scripts. So first thing we want to talk about is variables. Okay, every programming language pretty much needs some notion of variable, and there's variables in bash. And assigning a value to a variable is as simple as saying I equals 10. Okay, now the value of I is equal to 10. I could also say j equals ten, that works perfectly fine too. There's no strong typing in bash. In C we have to say integer I, and then when we say I equals, it darn well better be an integer, right? Bash kind of doesn't care. Okay, I could say I equals 10, j equals ten, it's perfectly happy. So how do we look at the value of a variable? Well, there's a statement called echo. And echo is, like the echo in a canyon. If you say echo hello, it says hello. If you say echo weirdness, huh, it says weirdness, huh. If I say echo I, it's going to say I. Why? Because I asked it to echo the word I, and that's what it did. So if I want the value of a variable, I got to do something to tell it. I don't mean I mean the value of the variable I. And the thing we do is a $sign. So put a $sign in front of a variable. It says, show me the value of the variable. And if I echo $J, it shows me ten. And if I say x equals I, what do you think the value of $x is? I, 10, turns out to be I. But if I say x equals $I, then x was equal to 10. It's exactly the same as if I said x equals 10, because $I gets replaced by the value of I, which is 10. And now if I echo $x, it's the number 10. This is very literal, okay? Bash is very much, that's what you told me to do. It's like rm-rf tilde will remove all the files that you have on your system. That's what you told me to do, okay? So, if I say echo 10 plus 10, what is it going to tell me? 10 plus 10, you got it. Okay. If I say echo $i plus $i, that's still 10 plus sign 10. There are some weird characters in bash. If I say echo asterisk, oh, it's not weird actually. Okay. Ooh, that surprises me. Alright, forget I said that. Alright, so echo will let us do output, right? And we can do things like put things in quotation marks. So it's the same as if we don't have quotes or quotes. But we can do something like this. The value of I is $i. And what is that going to echo? It's going to say the value of I is, but $i will get replaced with the value of I. So it says the value of I is 10. So this is probably a lot easier than like printf and %d and all of that stuff, right? Just throw a $sign in front of something and it gives you the value of it. And we use quotation marks a little loosely sometimes. You put things in double quotes to kind of logically say this is one thing, right? And I want to echo one thing. But here's the bigger reason. So name equals Nick Macias, and it gives me an error. It says Macias command not found. So if I had said name equals quote Nick Macias, that works great. So spaces are really, really significant in bash. They're almost completely insignificant in C. You can put spaces more or less anywhere you want, except in the middle of a variable or something. But bash, spacing is really critical. And if I say I space equals space 10, it says command I not found, but can be installed with sudo apt install iprint. Well, I don't care about that. And if I say I equals space 10, it says 10 command not found. And I space equals 10, well, there's my big long message again, and so on and so forth. So no spaces allowed.
Can you wrap things in parentheses?
Like
Like the 10, for example.
parentheses are weird. Generally, we won't use parentheses. But if I actually wanted I to be, parentheses 10, I could do this. And then I is parentheses 10 close paren.
So what if you wanted to print, like the previous thing was the value of I is $i, but if you actually wanted to print $i.
Ah, okay. I think you can put a backslash in front of it. And that says treat this as a character, don't interpret it.
What if you do a $sign in front of something that's not declared?
Then its value is just blank. So really forgiving, but that can also be a bummer with typos. Because in C, if you use a variable that you haven't done something with, you usually get an error. Bash, it'll just be like, yeah, that doesn't have a value. I'm good. And for now, stick with double quotes. Single quotes are also a thing, but they're a different thing. Okay, and let's not talk about single quotes yet. All right, so we got variables, we've got ways to do output. Let's talk about input. How do we input something from the user and assign it to a variable? Just the read statement. So we can say read name, and I can say my name is Nick, and if I look at the value of $name, it's equal to Nick. So read variable. Almost couldn't be easier. So let's make a script. So I'm going to put bin bash in the beginning. and then putting some comments in my code. So it says read someone's name and say hi to them. So I'm going to say, who are you? And then I'm going to read user's name. And case is important in Bash if you haven't noticed this already. Right? Uppercase I would be a different variable from lowercase I. So I'm going to read user's name, and then I'm going to say hi to them. Echo hello $ user's name. Nice to meet you. So we can run that, we can just say go, and it says permission denied. Yeah.
Could you do read prompt? Would that be the same as saying echo and then?
Yes, it would, but I'm going to say don't do that,
Oh, okay.
because it breaks the ODP sometimes,
Okay.
for reasons that we can get into later.
Okay.
But yeah, that's exactly the same thing. Alright, so what went wrong here?
Permissions.
Permissions, right? I did that on purpose. No, I didn't. I just forgot. So change mode 755 go. Now it's executable. Say go. Who are you? So who am I? I'm the Goblin King, right? So hello GK, nice to meet you. So pretty straightforward. All right, good so far? Yeah.
Can you explain read a little bit, the line that says read user name? What is that?
So when you say read followed by the name of a variable, the bash system waits for the user to type something and hit enter.
Oh, it's-
And then when they hit enter, whatever they type, that becomes the value of that variable. And that, could be things with spaces and $ and weird characters. And it's just all part of the variable. I'm going to change my name on Discord now. All right. So everyone's still here? All right, let's do arithmetic. I equals 10. Echo $i plus $i, 10 plus 10. Not very much fun, right? Okay, there's a weird syntax that we use to do arithmetic, which is $parentheses, parentheses, and then we can put an expression inside here, and that will actually get evaluated the way that we would expect it to. So I could say, for example, I plus I, and then we end with 2 closing parentheses. And if we do that, that's going to show us 20. So we can modify our script to show the square of a number. I am not typing well today. Okay, so let's say enter a number and read number, and then let's say the square of $number is $paren, number times number. So let's say go, so somebody give me a number, integer, 5. Square of 5 is 25. Yeah.
Do spaces matter when you're doing arithmetic like that? Like,
I don't think so. Yeah, you can get away with it in there, but don't.
why?
Because it's almost the only place where spaces will let you do that, or it'll let you do that with spaces.
Oh.
And so habits are good. And this space thing haunts you everywhere. Right? If you try to set up an alias new to mean print working directory, you get 3 errors from one command, which is pretty good. Right? If you do alias new equals pwd, that works fine. Alright, we got variables, we got ways to output, we got ways to input, we got ways to do arithmetic expressions. We've got everything we need for ODP 403. Okay, that's more than you're going to need. So let's take a look at the ODP. Alright, so ODP 403, you're writing a shell script again, not a C program. Okay, shell script. It should read one line of input from the user, treat that as an integer, print out 2 times that integer. That's it. Read a line, double it, print it out. So if you run this, type in a value of 12, it should print out 24. And there should only be one thing that your program prints from the time it starts to the time it exits, and that's 2 times the number that you put in.
It doesn't ask questions or...
Doesn't ask questions, doesn't say welcome to my ODP, doesn't say please enter a number, doesn't say the answer is 24. Okay, it's completely silent, waits for you to type a number, prints out twice that number. And that's important for the ODPs because the ODPs are automated and they'll get tripped up if you have, say, something that says enter a number, it'll say, oh, 0 out of 10. So let me show you what this should do. Okay, so I called my program GoodProg. So I hit enter to run it, no output. Okay, it just sits there. I type in 543, hit enter, it prints out 1086 and it exits. Okay, that'll assess for 10 out of 10. And there's 3 tests that get run on this ODP, so you'll see 3 sets of results, and you want each of those to be 10 out of 10. And then when it gets tallied, it should be 30 out of 30, and when it goes into Canvas, it would be 100. So every ODP is worth as much as every other ODP, whether it has 1 test or 10 tests. They're each worth 100 points, basically. And I'll load the first set of scores into Canvas over the weekend. Alright, so questions about this? And we've done something more complex than this already, right? We wrote something that reads a number and prints out the square of the number, but it also prints other stuff, right? So get rid of the other stuff and just print out twice the number. Yeah?
So how could you like reassign a value to the variable after like doing some math to it?
Oh, good. So, what's I equal to? I is equal to 10. So I could say something like I equals $paren I plus 1. And now, I is equal to 11. Right? Or I could have said J equals $paren I times 2. And now J is equal to 22. So it's a peculiar mechanism compared to C, right? But it's a parallel set of things that you do. It's just got the weird $paren syntax, but the stuff you do in C you can do in Bash. So while we're here, Echo has a number of options available for it. If I say man echo, it will show me different things I can do to tweak the behavior of the echo statement. For example, if I say echo dash n, it says don't output the trailing new line. When I say echo hello, it doesn't just say hello, it says hello followed by a new line, a backslash n. I can tell it not to do that by saying echo dash n. And that might be useful, because up here when I said enter a number, remember when I ran this, it said enter a number and it came down to a new line. If I were to say echo dash n, enter a number. Now when I run this, it says enter a number, but my little blinking cursor sits there on the same line. It's clear what it's asking me to do. It's asking me to enter a number. And so I can put that in and get the square. So that can look nicer from the user perspective.
How large can it handle?
Good question. So questions like that, best way to find out is you know, try it. So 100,000 seems to work.
I entered a really
Million
big number
seems to
and it
work.
went
So that's clearly not correct. No, even that worked. Let's try one more. 'Cause I'm guessing 4 billion. Yeah. So I think 4 billion, roughly, 2 to the 32nd. But we could find out pretty easily. We could write a script that takes a number and doubles it and then divides it by 2 and compares it to the original and sees if it made a mistake. And we could keep bumping up that number until it makes a mistake.
You'd need a for loop.
You need a loop of some kind, yeah. Which, guess what we're about to talk about. So any other questions? And read also has some options we can use. We can do the secret option with a -s switch, and so when we enter our number, it doesn't show us what we're typing. So if you want to enter a password or something, you can do that. And it doesn't do the kind of annoying thing of showing you a dot each time you hit a letter so that somebody spying can tell how long your password is. All right, why do we do that? Why do we show the dots?
So
I mean,
you
it's-
can tell how long it is.
So you can tell that you're typing something, right? If you don't believe that, you know, if you don't trust your keyboard or your senses or something. It's partially a remnant of the days before CRTs. Your terminals were basically printers. They were like big typewriters, and they had a print head that would move across and it would print everything that you typed, right? Because CRTs weren't really a thing yet. They were super expensive and kind of rare. And so imagine you're typing and everything you type, you're getting a physical hard copy of it, which was great for learning programming. Because when you were done, you could just grab this big bundle of paper and take it home with you and like relive what you did and look for bugs and stuff like that. But it was a bummer when it came to passwords, because you type in your password and your password would appear on a piece of paper printed. And then if you just like threw that away, or if maybe someone went through the garbage later on, right, that would be bad. So when passwords got printed, usually it would do something like this. It would print a bunch of M's, and then it would back up and it would print a bunch of X's, and then it would back up and it would print a bunch of W's, and then it would back up and then it would let you start typing here. And you would type your password, but there'd be all this ink that would be typing on top of, and if you just looked at it, it would just look like a blur of ink, and you couldn't actually tell the password. And I've got a feeling that's part of why we print out dots now when we put in passwords, but it's actually like weakening the security of it.
Unless you randomize how many dots per character.
Yeah, which would be cool. Just throw out some number of dots. Why don't they do that, man? There's your SLP. SLP and a patent. All right. This was weak security, by the way, because if you pulled out the typewriter ribbon, the characters aren't on top of each other just because you backspace. They're still side by side. So you just look past the W and the M and the X, and there's the password in plain text. Not that I ever did that. All right. So there's switches you can put on read, and there's a secret switch. You can put a timeout switch. You can have it only take a certain number of characters, and all kinds of things like that. So let's do some looping. To do useful programming, you need sequential statements, assignments, reads, writes, things like that. You also need conditional statements, if-thens, and you need loops, while loops, for loops, do loops. If you got those three things, you can do anything. Okay, your programming language is as good as any other programming language. So let's make a loop. So loop example. Let's start from 1. All right, so we're going to make a while loop. We can do for loops, but whiles get you fors for free, so let's do a while loop. So the while statement has a very strange syntax. While space, double bracket space, and then whatever the condition is for the while loop. So let's loop while I is less than 10. Or let's say less than or equal to 10. We'll go from 1 to 10. So while bracket bracket, $I, because I care about the value of I, not the symbol I, right? $I space. And we can't say less than sign equal, because it's bash. We have to use this kind of quaint -LE, which means less than or equal to.
-L would just be less than.
-LT would be less than. So they're all 2 characters. And I'll show you where those are. Okay, so while bracket bracket space, $I space, -LE space, 10 space, closing brackets. New line, we say do, and then we can put in everything that we want to do inside this loop. So I'm going to echo I equals, I'll show the value of I, and I'll laugh. And I'm indenting, that's just a style thing. That's so that I know when I look at the code that I'm inside some sort of loop or if statement or something. Bash doesn't care about spaces in the beginning of a statement. Don't forget to bump the loop variable. I probably forget that about 90% of the time I do this.
What is that? Like, bump the loop.
So the word do is kind of like the opening curly bracket, and the word done is like the closing curly bracket. It delimits the body of the loop. So while condition, do, curly bracket, bunch of stuff you want to do, and then done, closing curly bracket.
You meant bumping the loop variable. Like, what do you mean by that?
Adding 1 to it. It's bumping up the value.
So it's not infinite.
So it's not an infinite loop, exactly.
Is there any shorthand for incrementing?
I think it knows I++. We can find out in a second. All right, so let's run this. Go does our while loop. I equals 1 to 10. Haha, we're done. So let's do I++. Does not seem to work. All right, so I got an infinite loop here. How do you stop an infinite loop?
Control-C.
Control-C, excellent. Okay, hold down Control, hit C. Do not use Control-Z. Control-Z will also stop your, it will get back control of this, but it does something entirely different. And this is one of these things where if you go online and you Google how do I stop a bash script, half the answers you get will say use Control-Z. And if you do that, yeah, it gets me back to where I am, but it doesn't actually kill your script. Your script is still hanging around in the background, taking up resources. And eventually this will get you locked out, and you send an email, and I'll look and I'll say, oh, you've got 15 scripts that you've stopped by doing Control-Z, and I got to go kill them, and then you can get back in. So Control-C.
Would you kill them after that?
Hmm?
Like, how would you kill it?
So if you happen to do this, if you happen to do Control Z and you're like, oh, I wasn't supposed to do that, I'm going to fail the course, right? Relax, just do an FG. FG means take that job that stopped, bring it back into the foreground. And that gets it running again, and then you can do Control C.
There's no way to do it without going back.
You can kill it too, but I'm going to do processes later on. So you could just say kill space %1. Yeah.
What is dash value mean?
What is what?
Dash value.
In the script?
While
Dash LE?
Yeah.
Okay, so let me fix this first. Let me tell you where you can find all of these. So on the Canvas page, on that top area resources, there's something about 2/3 of the way down, if, for, while, etc. in bash. This is your favorite document for a while and when you're doing tests and stuff. So while statement, while space, blah, 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 condition, okay? Comparing numbers, integers, you got to use one of these symbols. Okay, dash LE is the one that means less than or equal to.
They're pretty common sense though. Like
They're pretty common
greater
sense,
than,
yeah.
greater equal.
If you speak, yeah. All right, so really important note here, okay? It's the last 2 minutes, but this is really, really important, okay? There are a lot of ways you can write a while loop in bash. There are a lot of ways you can assign a value equal to twice something. There's a lot of ways you can write if statements, okay? Sometimes you can write a while loop with just one bracket. Sometimes you can do a comparison of numbers with equal sign instead of dash EQ. Or an if statement with parentheses instead of brackets. And sometimes these will work. Sometimes they'll just plain throw up all over your screen. Sometimes they'll work, but most often they will work some of the time, but not all of the time. Okay? And chances are, when I'm looking at your code or when it's being assessed, it will be using test cases that will make your code blow up if you're doing something different from this. So I'm going to insist, and I debated this a long time over the summer, I'm going to insist that when we do bash for assignments, for homework, for ODPs, on exams, if you're writing a while loop, it's got to look like this. Okay? And I'm not talking about indenting the statements or things like that, but it's got to be while space, bracket, bracket, space, condition, space, bracket, bracket. Do statements done. And if you're comparing strings, use equal, equal, or exclamation equal for not equal. If you're comparing numbers, do these things.
So you need spaces as well for while loops.
You need spaces before and after the double bracket and before the closing double bracket. And if you do it like this, it will work. Okay, if you do if statements like if statements are described in here, they will work. If you do a different version of an if statement that happens to work, you won't get credit for it. Okay, and so this is why I apologize. If you already know bash and you're already a proficient bash program and you know how to do if statements with parentheses or single brackets, I'm sorry, but I'm going to force you to do it like this for this course. Okay, because it's too easy to, you know, look up something online or make a guess and come up with something that kind of works sometimes or maybe works for this particular problem but doesn't work in general. And I want to make sure that everybody knows how to do it at least like this. There are other ways. There's better ways, there's worse ways, but I'm going to insist that you do it the way that's described in here. So this is your reference guide when you're doing shell scripting with loops or conditionals. And we'll talk a lot more about this tomorrow. Yeah, so for an if statement, the word then is the opening bracket and the word fi is the closing bracket.
Oh, the closing bracket.
Yeah.
Okay.
If and 5.